In this video, we will talk about how to find the distance from a point to a line. So let's check out this example here. Let's say we have a line with an equation y equals 2x plus 3, and let's say we have a point located at 6, 5, and we want to know the distance between this line and this point. So I've outlined a 3-step process we can use to find that distance. So step 1 is we need to find the equation of the perpendicular line. So the equation of the line that is perpendicular to this given line right here. So we know that this given line has a slope of 2 because it's in the format y equals mx plus b, where m is the slope. So the slope of this line is 2, if we want to write 2 over 1. The perpendicular line will have a slope that is the negative reciprocal of this. So the reciprocal just means you flip the numerator and denominator, and then we make it negative, so we reverse the sign. So the perpendicular line will have a slope of negative 1/2. So if we want to write the perpendicular line in this format of y equals mx plus b, we know m, we just need to figure out what is b. And to do that, we need to plug in values for x and y of some point that lies on the perpendicular line. So the perpendicular line right here is going to contain the point 6, 5. So we can plug in a 5 for y and a 6 for x. So let's do that. So we'll say 5 is equal to negative 1/2 times 6 plus b. So we get 5 is equal to negative 1/2 times 6 is negative 3, plus b, we can add a 3 to each side to solve for b. 5 plus 3 is 8, so we get b is equal to 8. So the equation of this perpendicular line right here is going to be y equals negative 1/2 x plus 8. So that's the first step, so I'll make a little room right here. Okay, so we did step 1. Step 2 is find the point of intersection between the lines. So we want to find where this line and where this perpendicular line intersect. So the way that we do that is we simply set them equal to each other and solve for x. And once we have x, we'll be able to solve for y. So we can say 2x plus 3, so this line right here, is equal to negative 1/2 x plus 8. So this perpendicular line we just found. Now to solve for x, we can start by multiplying every term by 2 just to get rid of this 2 in the denominator here, so we don't have to work with fractions. So we get 2x times 2, that's 4x, plus 3 times 2 is 6, is equal to, when we multiply this one by 2, we just get a negative 1x, and then 8 times 2 is 16. So to solve for x, we can add an x to each side, and then we can subtract a 6 from each side. So we get 4x plus x is 5x, these 6's cancel out, is equal to, these x's cancel out, and we have 16 minus 6 is 10. To solve for x, we can divide both sides by 5, and we find that x is equal to 10 divided by 5 is 2. So x is equal to 2. Now we just need to plug that into either this equation or this equation and solve for y. So let's plug it into this equation. So we get y equals 2 times 2 plus 3. So y is equal to 2 times 2 is 4 plus 3 is 7. So the point of intersection is 2, 7. So that's where this perpendicular line and this line right here, that's where they intersect. So I'll make a little room right here again. Okay, the last step, step 3, is find the distance between the point of intersection and the given point. So between this point of intersection and this given point of 6, 5. So the distance between those two is calculated using this formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. So if we call this point x1 and y1, and we call this point x2 and y2, we'll just plug in all of those values into this distance formula. So we get 2 minus 6 squared plus y2 is 7 and y1 is 5. So 7 minus 5 squared. So we get the square root of 2 minus 6 is negative 4. Negative 4 squared is a positive 16. Plus 7 minus 5, that's 2. And 2 squared is 4. So we get 16 plus 4. So our final answer is the square root of 20. And if we'd like, we could simplify this by writing it as the square root of 4 times the square root of 5, since 4 times 5 is equal to 20. And we'll notice the square root of 4 is 2. So we can write our final answer as 2 root 5. So this is the distance between this point and this line. And if you were to punch it into a calculator just to get a decimal answer, it would be about 4.47. but usually I like to leave it in this format because it's an exact answer. So that is the 3-step process that you can use to find the distance from a point to a line.